Okay, good afternoon, everyone. Right. Please have your camera on. As I always said, please have your camera on. Questions? How did the homework go? Okay, if anybody has any questions, please put them on chat. Can we go number 11 and 12, please? I do, but which section, Elizabeth? Okay. All right. Okay, please put your camera on because it helps me a lot when I am working with you. It helps me to see your faces. Thank you. Thanks, guys. All right, so I will start with 2.1. It's number 8. Okay, thanks. All right, so let's do that. So the question is about the domain and the range. Let us recall the domain are all the X values. It means all the input values. Such that f of X yields a number. All those that yield a number. A real number. That's really how we're defining that in this context. And the range are all the output value, all the Y value, all the output values. Okay. So with this in mind, let me go through your questions. So if I start with 2.1, it's number 8 and number 12. Okay. Okay, number 2.1, number 8. All right. Number 8, and the question was, I forgot what I assigned, D. All right, so we'll do that. All right. I'm trying to read what your questions. There are so many. I'm trying to figure them out all. So 2.1 number 8, I got that. 2.2 number 8, I got that. 2.1 7D. I did not assign 7D if my memory is correct, which is I think it is. I'm sparing you that problem. So instead of 7D, I'm going to do number 3, which is easy, just to get us into the picture. And then I'll pick up number 8. All right. So that's how we will do it. So number 3 is we have the following function, f of t equal the square root of 25 minus t. Okay, that's number 3, just to get started. And the question is find the domain. All right. What did you guys come up with and why? Okay. So I would like a minute. I'll give you a minute. So for you guys to tell me what's going to be the answer. What did you guys come up with? And where did your answer come from? Not only the answer and where it came from. Okay. All right, so one student is telling me all values of X. So I will write what she said here. All values of X, of T. Yes, you guys are right. Such that, and the answer was T less or equal to 25. Okay, that's the answer I've seen. Okay, now I want you to tell me, how do you get that? Okay, so your answer is maybe correct, most probably it is, but how do we get the answer? What is it we have to solve to get the answer? Back to you. So what is it we have?
You equal it to 0, so it'll be 25 minus t equals 0.
We don't equal it to 0. What do we do with it?
More than or equal to 0.
That's better. That's what we want. We want this term under the square root to be bigger or equal to 0. That's for the domain. These are the allowable values of t. And then we're going to solve for t. So let us say I solved it this way. I subtracted 25 from both sides. Let's say I did this way. And then to isolate 25 t, I divide by -1. When I divide by negative, I have, so here divide by -1. Both sides, or multiply by -1. I need to change t less or equal 25. So this will be the allowable values, t less or equal 25. Any value larger than 25 will make the term under the square root to be negative number. So it means like if I take t to be 26, let us say, if I plug in 26, 25 minus 26 is the square root of -1. It's not an allowable value. The only allowable value for t are less or equal to 25. That would be my domain. Okay. Okay, and problem number 2, and then I will pick up number 8 because it's combining the two ideas together. So I will pick up, for example, I don't know, number 8, part B. Part B. And then I will do D. B is f of x equal x plus 3 over x plus 2. And the question is the domain. All right. Okay. I'm looking at your answer. I'm looking at chat. And I want all of you to participate, not the few of you. Quickly, I want a quick answer because you're supposed to have done this problem. Okay. Anybody else? Anybody else? I have one answer. I want more. Okay. So everybody telling me all values of x such that x is different from 2, from -2. My apology. Okay. You guys are absolutely correct. Where did you get the -2 from? What is it we have to solve for? What is it giving me a headache in this problem? Quickly. What's giving me a headache? I don't have a square root. So what's giving me a problem? Which axis will give me a problem? I have a denominator. I have to avoid every x that makes this denominator 0. Because there is no square root to deal with, but I have a denominator. I have to remove every x that makes the denominator 0. So I ask myself, okay, what makes this denominator 0? -2 will make it. There is no square root. I don't have to worry about positive, negative. There is none of that whatsoever. Only thing I have to worry about is I want to avoid everything that makes the denominator to be 0. All right? So the denominator is 0 for -2. I have to remove it. So everything will be allowable except -2. And one more time, the reason is because if I input -2 into the formula, I will get -2 plus 3 over -2 plus 2. I will get 1 over 0, which is not defined. So that's really what's causing the issue. If I input -2, I don't have a number. It's 1 over 0. Questions? Okay, now I finalize with the question that you guys asked me about, which is the following. What it is? F of x equals, so it's part D, is section 2.1, number 8, part D. F of x equal the square root of 36 minus x divided by x plus 8. Okay. Now, I'll give you a minute to tell me what the domain is. And in the meantime, you have to tell me where you get your answer from. Please, those who don't have their camera on, I really appreciate it if you put it on. Not only your picture, I want your faces. All right, I'll give you a minute and then I'm going to pick one student and see what they came up with. Okay, I'm starting to have answers. Anybody else want to put anything? Analyze what you have. Analyze what you have. What cause issues? Which input will not yield a number? Okay, so I'm having one answer. All values of x does not equal to, so I'm going to write what I see. X is different than -8. Is this a correct? That's half of the story though. Why x has to be different from -8? Because I do have a denominator, it's x plus 8. So I cannot have 0 in here. So I'm going to take care of the denominator. So I said, okay, this is 0 when x equal -8. So we need x to be different from -8. Is this the only issue I have here? Who can pinpoint another problem I have?
I have a quick question.
Yes.
Okay, so why is it for D that it's not like a less than or equal to, but it's like an except, like with the equal sign and cross through? Like, how do we know when to use it and like use the less than or equal sign and then versus the
It depends on what you have. You guys are starting to give me good answers. Now you guys are better. Is there a square root term here? The denominator only involves x plus 8. So the only thing I need for the denominator is to avoid the 0. So the denominator will tell me you cannot take x to be -8. That's it. It can take any other value, the denominator is telling me. -8 has to be avoided because it makes the denominator 0. That's what the denominator is telling me. But now what's the numerator telling me? The numerator involves a square root term.
So that would have the less than or equal.
Exactly, because there is a square root term. Is that clear? That's why I wanted this problem, because it got both pictures at the same time. So the numerator tells me, you know, this will make the only input you can plug in here are those that make this positive. So I know this to be positive. It means that 36 bigger or equal to x. It means x has to be less or equal to 36. So now I need two things. So this problem gives me two conditions on my x. I first have to guarantee what's under the square root to be positive. But this tells me that your x has to be less or equal to 36. The denominator tells me that your x cannot be equal to -8. So the domain is going to be all x, such that x different from -8 and x less or equal to 36. Is that making sense? So this problem is really mixing both ideas. So which x's I can put? Everything, as long as it's not -8, as long as it's less than 36. So if I put 37, it's nonsense, because if I put 37 for x, it will give me the square root of 37 minus 36 minus 37, which is the square root of -1. So if I put 37, I will have -1. The denominator isn't giving me a problem, because 37 plus 8 is going to give me 45. So the denominator isn't giving me a problem. What's giving me the problem is the numerator. So I have to take care of two problems here. I want to make sure this is positive, and I'm going to avoid the -8 to make sure that the denominator is not 0. Whoever asked the question, is this making sense? Right. Okay. Any other questions about the domain idea? Okay. I will do one more simple problem, and let me see what it is. Suppose I give you f of x equal, not the square root, the cubic root of x plus 1, let us say. Okay. What's the domain here? And before I ask you this question, let me ask you the following question. What's the cubic root of 8? What's the cubic root of 8? It means what is the number such that when you take it to the power 3, you get 8? Quickly. 2.
2.
What's the cubic root of -8? That's the cubic root. It means what's the number? When you take it to the power 3, you get -8.
-2.
-2. So if I have a cubic root, I don't have any problem. The number here could be positive and could be negative. Very different than the square root. For the square root, it has to be positive. The cubic root, I don't need positive, because if I have negative, there is no problem. And if I have positive, there is no problem. So what do you think the domain is going to be now? And the domain is going to be all values of x. Absolutely. Brandon is absolutely correct. All values, there is no issue, because if this is a positive number, there is no problem. If it's negative, there is no problem. The domain is everything. I can input anything, I will have a number. But there is a difference between the square root. The square root only involve, we should have positive numbers. For the cubic root, anything. Any number will do. So there will be no issue with the number you input. Okay, so that's the idea of the cubic root. They don't give me any restriction. I can put anything under it. This one, the square root, is problematic. That's why we worked with it. Right. Now we're going to look at the range, because that's what your questions were. And then we're going to move on to the piecewise defined function. All right, for the range, as I said last time in class, the only way I can figure out the range is from the graph. So whenever you want the range, we graph the function and we get the range. So I'm going to look at number 11 and number 12. This is the picture from the book. And the question is, what is so below on the left is the entire graph of a function. On the right is the entire graph of function g. The question is, determine the domain and the range of each one of them. Remember, domain are the x values. The range are the y values. Okay, we start with the one in the left. What is the domain? It means what are all the input that yields an output, that yields a number. Okay. And this time I'm going to pick one of you, just because I want everybody to be everybody to participate. Okay, let us try Cindy Mora. Any idea? First, Cindy, are you with me?
Yeah.
Go ahead. What do you think the domain?
You would put a bracket in -3.
Uh-huh.
And then -1 in a parentheses.
-1 into parentheses. Very good.
And then You would put the union sign, the
Oh, wow. Okay, so you know a lot of this stuff. What should go here?
0 and 3 in brackets.
Absolutely correct. So let's see what she said. I did not introduce this notation in class. What this notation union mean, it means everything in here and everything in here. That's what this notation means. You don't have to use it. I don't really force you to use it, but this means that everything in this interval is in the domain and everything here is in the domain. And it's very good because from -3 to -1, if I give you any number here, tell you find the output, you know, we don't have a problem. I can give you the output. But from -1 to 0, if I give you a number here, there is no output. There is no graph in here. So these are not in your domain. So what's in the domain? Everything between -3 and -1. So you can either write this notation or you can tell me all the x value such that x in this interval or x in this interval. So you don't have to use the union. Doesn't matter. You can use this notation. What's the range? What's the range? I'll pick another student for the range. I'll put Jared. Jared, are you with me?
Yeah.
Oh, yeah, you are. Sorry. Okay.
Yeah.
What's the range? Range are all the y values.
Would it be 0, 6?
0, 6. So yeah, 0 is in the range, 1 in the range, everything in the range, 6. Is the 6 in the range or not in the range? It means, shall I close it or keep it open?
You would keep it open.
Okay, let me ask you, can you give me an input whose output is 6? This is closed. Is there a value of x such that f of x is 6?
No.
Are you sure? Yeah, you have to look carefully. Yeah. Yes, you have to look carefully. This is 6.
Yeah.
Can you give me right there?
So it'd be -3.
Right. So it's 6 in the range.
So then,
yeah, because what does mean in the range? It means, can you find an input which output is 6? And the answer is yes, we have to close it. Okay? What does it mean in the range? It means, can you give me an input where the output is 6? If we look closely at the graph, yes, because -3, f of -3 is 6. So this is in the range. It is an output value. But anything bigger than 6 is not an output value because there is no input that brings me an output of 6. Right. G, what's the range of G? Okay. I want the range. I'm going to ask another student for the range. So look at it and I'll pick. Ryan Mayton, are you with us, Ryan? Ryan? If the student is not with me, I move on. Ryan, are you with me? Okay. Zach? Zach, are you with me? Okay, I'll count you absent. All right. Anybody would like to answer? I don't want to push anymore.
Is it -6 to 0?
-6 to 0.
Inclusive?
Okay. So which one is inclusive? Is it both of them?
Both.
All right. So let me see.
Actually, it's -6 open dot. I can't really see.
Absolutely. Yeah, because this is an open circle.
Oh, okay, that looked close to me. Okay.
Yeah. Okay, that's an open circle. It means -6 is not in the range. -6 is not, this point is not part of the graph. The graph stops at -6. So what's the range? Everything from -6 to 0 is, so this is the range from here all the way to here. That's the range. They are the output values. And the domain here is always the input values. Okay. Any other questions before I move on to piecewise defined function?
So do we not have to find the domain for that one?
No, don't worry about the domain. Don't worry. Okay.
So
Let me write it down though for you to make sure for the domain. Be very clear. What's the domain? Everything up to here is in the domain. And everything from here to here is in the domain. So the domain is skipping this value, this piece. This piece is not, because if I give you any input here, what's the output? You're gonna look at me, tell me, but there is no output in here. There is no part of the graph. There is no graph in here. So the domain is going to be all values of x such that what? X between -3 and 0, or between 1 and strictly less than 4. 4 will not be included because, sorry, strictly less than 3. 3 is not included because if the input is 3, that's open. So 3 will not be part of your domain. So the domain has a hole in it. Sometimes you call this a hole in the domain. It's from -3 to 0 and from 1 to 4. And there is an open piece. That's a hole. It's not part of your domain.
So if you were writing it with the U
interval sign, yeah, you write the following. Close it at -3. Close at 0. This is called union. It's like a cup.
Okay.
Union. The interval open at 1. Close at 3. Sorry. Close at 1. Open at 3.
So whenever it's a closed circle, it's a bracket, and then when it's open, it's a
Yes,
parentheses.
that means
Okay.
this means 3 not included. 1
Okay.
included. 0 included. -3 included. Everything between -3 and 0 included. So -2, -2.5, -2.3, all of those are included. Are you with me?
Yes.
Yeah. And the union, so instead of writing, in math, we try to create notation to make things easier. So instead of, but I didn't know you guys were aware of it. That's why I dropped it. So instead of writing all this, we write that, which reflect everything here and everything in here. All right.
Okay. Thank you.
Sure. Anything else? All right. So now, as I said, we're going to move to the idea of piecewise defined function, and we're going to start working with them today. So it's section 2.3, I guess. Yep. So piecewise defined. Functions. All right. So before I do that, we're going to work with function that was, at least today, all my functions are given by formulas. And next time we'll give some application. Suppose I give you the simple function, f of x equal to x plus 1, for example. Okay, so I give you one formula, f of x equal to x plus 1. And in this problem, if I tell you find f of anything, f of 2 or f of 15, you just plug in the number here and you get, for example, whatever, this is going to give you a 5. Okay. And suppose I tell you graph f, sketch the graph of the function f. Okay. How are we going to sketch the graph of the function f? First, what we should notice that this is a linear function because it has the form mx plus b. It's linear, which means that the graph has to be a line. At least we know that much. The minute we have the power of x becomes square, the graph will not be a line, which we're going to be taking care of very soon. So the graph is a line. So if I tell you to graph it, you basically, it's easy because since it's a line, I can just find 2 points and graph the line. So supposedly, I pick any 2 points, x, f of x, to x plus 1. I pick 2 points. Suppose I can pick 0, and I can pick 2, and at 0 it's 1, at 2 it's 5. So to graph this function, because it's a line, otherwise I cannot do that easily, 2 points will do. 1 and 2, it's 5. 3, 4, sorry, 1, 2, 3, 4, 5, somewhere in here. And I connect, and I get the graph. Okay, so that's the graph of this function. So now if I tell you, okay, 3, and if I want this point on this line, okay, I know what it is. 3, 2 times 3, it's a 6, plus 1, it's 7. Okay, so that's a simple function. Now I'm going to add one layer. Suppose I tell you the following. Let f of x be equal. I'm going to restrict the domain where x is, let us say, less or equal to 2. Okay. This time what I'm doing is I'm giving you a function, but I am telling you that this function only makes sense. So that's, you can think of this as the domain of the function. But this function, that's the output only when x is bigger or equal to 2. So I'm not interested what happened after 2. So in this case, if I tell you sketch the graph is going to look like that. I'm going to actually stop at 2. So I'm going to graph this function, but instead of graphing it for all x like I did here, since the domain is less than 2, I stop my graph at 2. So what do I mean by that? Means that's 2x plus 1 from the previous section, but when x is less than 2, it means I stop my graph at 2, and I basically erase this piece. So when I change the domain, x less than 2, it means I'm interested in this graph up to 2. I don't care about what's happening after 2. So today we're going to take the following type of function. So that's generality. I'm going to take the following function. I'm going to tell you, let f of x be equal to. Now watch how I'm going to define it. I'm going to put a big bracket right there. I tell you, f of x equal 3 for x less or equal to 4, and 5 for x bigger than 4. So now I'm defining a function in the following way. The rule depends on where my input is. So this tells me that if my input is less than 4, the rule tells me that my output should be 3. If my input is bigger than 4, the rule tells me that my output is 5. So this time, I don't have one rule for all values of x. My rule will depend on the value of x. So let me ask you to do the following. Find f of 0. What's f of 0 according to this new function? So let's see how we do it. We take the 0 and ask ourselves, where is 0? Which condition does it satisfy? Condition 1 or condition 2? 0 is less than 4. So the rule tells me if your input is less than 4, your output is 3. So f of 0 will be equal to 3. That's how we are going to read the function. So let me take a bunch of numbers and ask you to write me the answers on chat. So what is f of 1? Okay, what is f of 1? So 3, because again, 1, I go here. Which condition satisfied? First is satisfied. 1 is less than 4. The output is 3. So I don't have one rule for everything. I really have to follow where my input is. Is it here? Satisfy this condition or that condition. All right, so suppose now I give you f of 4. What is f of 4? Anybody else? Again, 3, because
5.
No, not 5. Why? Why? Which condition does it satisfy? This or that?
It would be the first one because it is
Yeah,
less
so
than or
it would
equal to.
be
Exactly. Yeah, it says less or equal here. You guys see it? That's less or equal. So it satisfies this condition. So if my input is less or equal to 4, it's 3. So f of 4 is 3 in this scenario. Exactly. Now, let me do, of course, you know what I'm going to ask now. What if I put f of 4.1? Why not? That's the 5. Because 4.1 is larger than 4. I don't have always to give you integers. There is no reason I can do that. And then f of 5, again, 5. I go back here. It satisfies this condition. The rule tells me if your input satisfies this condition, your output is 5. So that's how we read this function. Now, problem number 2 is sketch the graph of f. Sketch the graph. Okay, means I want to plot all the point whose coordinate is x and f of x that correspond to this x. So let's see how we're going to sketch the graph. All right, so we're going to take 2 lines. Okay, that's the x value, and this is the f of x. Okay, and I'm going to rewrite the function here, so I don't have to pull the paper. So that's my function. F of x is 3 for x if x is less or equal to 4, and 5 when x is strictly bigger than 4. So this is really my rule. So how do we sketch that? It means I want to sketch all the points such that satisfies the rule. Okay. The way we're going to sketch is like this. The rule is changing at 4 for x less than 4. So I'm going to put 4 here. Up to 4, whatever the input is, the output is 3. So I'm hiding on purpose because I want to focus on that. So if I take any input less than 4, so I took 0, the output is 3. I take 1, the output is 3. I take 1.1, the output is 3. I take 4, the output is 3. So as long as I am less than 4, the output is always constant. It means the graph is a horizontal line like that. And this is a full circle because if x is 4, because inequality, the output is 3. So that's the first piece of the graph. That's where the word piecewise will be. Now I'm going to sketch the bottom piece, bigger than 4. All right. If I take anything bigger than 4, I take 5. The output is 5. So suppose this is my 5 here. So this is going to be 5. If I take anything bigger than 4, 4.1, the output is 5, and so on and so forth. So this is going to be all 5. But now I'm going to have an issue right there. How I'm going to show what's going on exactly at 4. The way we're going to describe this is full circle because the functions take the value 3, and this is I'm going to put as an open circle because at 4, the function doesn't take the value 5. A little bit more than 4, it's 5. But at 4, it's not 5, it's actually 3. So this is going to be an open, and it's going to be a close. And that's going to be the graph of the function. That's how graphically we represent the function. So the reason we call it piecewise, because this function is in 2 pieces. So the way we graph it, we graph the first piece up to 4, and then we graph the second piece for x bigger than 4. Right? So I'm going to do one more problem myself, and then I'm going to let you do a problem on your own. 2 problems, hopefully we can go through them today. All right, so example number 2. Again, I'm taking simple example. So example number 2. So how to basically read those functions and how to really graph them. I'm going to take f of x is, let us say, x plus 2 for x less or equal to 4, for example. And I want it to be 8 for x after that, strictly bigger than 4. Okay, actually, I don't have even to have 4. I don't want to, sorry, I will change 4 because I don't want you to think it's always 4. So I'm going to put 1 here and 1 here. And the question is, first, let us understand how the rule works and then how to graph it. So find the following. F of minus 1, f of 0, f of 0.9, why not? F of 1, f of 1.5, f of 2. Okay. All right, so let's get going. What is f of minus 1? Now it's up to you. Okay, what's f of minus 1?
X plus
Okay.
2.
Minus 1, so I take minus 1 and ask myself which condition it's satisfied. Minus 1 is right there. So the rule that it follows is this rule right here. So I'm going to plug in minus 1 into this rule. So it's minus 1 plus 2, which is equal to 1. Okay, so here we say that the rule for this one is x plus 2, but I have to substitute minus 1 for it. F of 0. 0. I go back here. Which condition satisfied? It satisfies this. The rule is x plus 2. So this is 0 plus 2. This is equal to 2. F of 0.9. Quickly. What's f of 0.9? Okay, the rule is, again, x plus 2. So it's 0.9 plus 2. So it's 2.9. So that's really the output value. F of 1. F of 1 is 3 because 1 satisfies this condition. F of 1.5, very quickly. 1.5, it's 8 because it satisfies bigger than 1. So that's the rule, and this is equal to 8. And so that's how we're going to read those functions. Question number 2 is sketch the graph. All right, sketch the graph. Okay. Let's see how we're going to sketch the graph of this function. All right. First, I'm going to write here the function again, the rule, and then sketch it next to it. So it helps us. So this is my function. It's x plus 2. The output is x plus 2 as long as my x less than 1. And the output is 8 as long as my x is strictly bigger than 1. So what does it mean to graph? It means I want here to sketch all the point that has for coordinate minus 1, 1, basically 0, 2, 0.9 to 0.9. This is really what I am really sketching, but I'm going to do it for all x. All right, how we do with that? As I did before, I will do it piece by piece. I'm going to concentrate on the first piece. And this work all the way up to 1. So up to here, I have a rule. And this is the piece I want to graph. Now, how shall I graph this? Okay, I will do it myself first. First, I should recognize that x plus 2 should represent a line for me. So the way we graph this is like that. On the side here, I'm going to do the following. Let us say I'm going to sketch the line f of x equal x plus 2 in general. Okay, how do I sketch this line? I said this is linear. The graph is a line. So if to sketch it, I need 2 points. So I'm going to draw 2 points. And so for example, at 0, I am at 2. At 1, I am at 3. So this will be f of x equal x plus 2. But in this problem, I am interested in this up to 1. So basically, I don't take the whole graph. I stop it at 1. That's really the idea. So I'm going to sketch exactly this, but I don't sketch it for all x. I stop at 1 because the output is given by this rule as long as x is less than 1. That's the idea that we're going to be doing. Okay. So now let me apply that. So I want to sketch of x equal x plus 2, this piece. I said this is a line. So to sketch it, I need 2 points. And the graph has to stop at 1. So I'm going to take 2 points to sketch it. So I take, okay, at 0, it's 2. So at 0, I am at 2. And then I need another point. It means I need to pick another value of x. So I said, you know, it's nice to know what happened at 1. So we take x equal to 1. This is going to give me a 3. So at 1, I am at 3. 3. So the way we're going to sketch it is this is a line up to 3. And if x equal to 1, I am at 3. We close that. And I stop there. That's the first piece of the graph. So I'm going to take this. That's the first piece of my graph. This is the x plus 2. So I sketch the line. I stop at 1. This has to be closed because if x equal to 1, the function is taking the value 3. I close it. Now the second piece. When x is bigger than 1. If x is bigger than 1, no matter what x is, as long as it's bigger than 1, the output is 8. So if this is 8, this is going to be an open circle. And then no matter what x, it's 8. So it's a constant function. The output is not changing. Constant function, the output is 8. And that's really the graph of this function. So at 1, let us focus what happened at 1. It's closed here because the function takes the value 3 at 1. It's open up here because that's the output at 1. It's 3. It's not 8. Okay. All right. Now what I would like you to do is the following. I did ask you to print a worksheet. I don't know if you guys done it. Did you guys print it? I doubt it. Did you guys print the worksheet I gave you?
I'm not gonna lie.
Okay, thank you very much. All right, so I'm gonna put it in front of us and we're gonna work on it together. So I hope to get 2 pages from it with you, all right? I know which is easy and I know which one is hard. Yeah, okay. B is hard, 1 should be easy. Okay, that's really it where it will work. Okay, so now I have a function and it's defined by the following rule. 2x plus 1 when x is less or equal to 3. That's the rule. And minus x plus 6 when x is between 3 and 6. This is the rule. We stop at 6. So I'm giving you the output from up to 6. 6 not included. And the question is evaluate each of the following. The first question should be easy. My numbers are different. Can't be. I know. That's what I'm going to be working on. Oh, yeah, they are different for me. Why?
Yeah, for ours, it's the second one. It's for 1 that is greater than x and then greater than 4. Yours is 3 and 6.
Okay,
And the
right.
first one.
Let's keep working with the one I have. My apology. Okay, let's keep working with this one. Can you fix yours? So f of x is 2x plus 1 for x less or equal to 3, minus x plus 6 for x between 3 and 6. My apology if it's different. Sometimes I change and I forget to change it on your right space. All right. Part A, I give you a minute to fill in the answer. My apology for those that I have the wrong one. So I give you a minute to fill out part A. Because I'm using the one I have here. I'm sorry, as I said again, because I will refix it. I will upload this one on Brightspace again. Are we ready? Yes? All right, let's go. F of -1. Alicia, what did you get?
I got 1.
You got 1. Why?
Because you plug it into the first thing.
Yeah, because -1 is less than 3, right? So I've plugged into the first. So I will get 2 times -1 plus 1, right?
Yeah.
And this should give me -1. Am I correct? Yeah. Okay, f of 0, Connor. Which equation you plug it in?
That one you plugged into the second equation.
Why?
So that the 3 is less than 0 is less than 6, correct?
Which one you're doing? Connor, which one we're doing?
I'm doing the f is 0.
Okay, we're doing that. All right.
Yeah.
Why in the second equation though?
I'll be honest, I don't know.
Okay, we look at the input 0, okay? And we ask ourselves, which conditions that satisfies, the first or the second? It means, is it less or equal to 3 or it's between 3 and 6? Which one?
Okay, so it should have gone the first one.
Exactly, because it satisfies this condition. 0 is less or equal to 3. So I use the first formula.
So
Plus
then
1.
it would be
Go ahead.
1, correct?
It will be 1. Okay? What about f of 1? Connor, you can stay with me. Which rule we're gonna use?
That one you would still use the same rule for.
Exactly, because 1 satisfies this condition. So it's 2 times 1 plus 1, which is equal to 3. Okay? Now, f of 3, anybody else? Seven, Jessica's giving me 7. Okay, which rule we have to use, Jessica? The first or the second? Jessica, can you talk or not?
Yeah, sorry. It will be the first one
Because?
because it is less than or equal to.
Right, we have less or equal, so we're still in the first one. So 3 satisfies the first condition. So it's 2 times 3 plus 1 equal to 7. Finally, f of 5. Okay, put it on Brightspace, your answer. Please, all of you. Okay, Allison, give me 2. I'm getting 2. 2.
On our paper, it's f of 4, not f of 5.
Okay, I'll do both. Let's do f of 5 first, because that's what I have here. So f of 5 is going to be -5 plus 6, 1. And f of 4, since that's what you have, we will do that. It's going to be -4 sits in between. So -4 plus 6, which is equal to 2. Okay? Very good. Now, graphing. And as I said, that usually is the hard part, but we're going to see how we're going to do that. So I rewrite the function because it's not in front of me anymore. I mean, it is in front, but I don't know if it's in front of you guys. So it's 2x plus 1. So it's this line as long as my x less or equal to 3. And it's minus x plus 6 as long as my x between 3 and 6. So this is my output. So my output totally depends on the input. So it's okay. So how are we going to graph this? Very good. Piece by piece. So I'm going to basically hide this and focus on that. So the output is 2x plus 1 as x less or equal to 3. So I'm going to go down here, and this is my 3 here. Okay, that's my 3. And I'm going to graph this function and basically stop my graph at 3. That's really how we do it. We stop the graph at 3. How can I graph this? And what does it mean to graph it? This is a function. It means if I sketch all the point that has for coordinate x, f of x, I'm going to get a line. So I know that this is a line. But I'm interested in this line up to 3. I'm not interested in it after that. So how to sketch this line? Okay. What's the easy way to sketch a line? Who can answer my question? What's an easy way to sketch a line?
By plugging it into a table.
Yeah, so how many input value you need to plug it into a table? How many value of x I need?
Do you only need just 2?
Yes, because if I have two points, I draw the line. Okay, it's not a curve. When things becoming like this, 2 points will not do. It's impossible. So that's the benefit of a line. Once I recognize it a line, because here I have power 1, I only need 2 input. Which are the good input that you want me to take? Which do you think will be important in this problem? Remember, the graph has to stop at 3.
We have to do f of 1 because that equals 3.
No, that's not because of that. 3 is an input value. Be very careful. Or have any idea? 1 and 3, that's possible. 0 and 3, it will go. I'm going to take 0 because it's a simple number. So at 0, I am at 1. At 3, when the input is 3, the function takes the value plus 1, which is 7. So now my line, at 0, it's take 1. At 3, it's 7, right here. And x is less or equal to 3. It means for 3, we get, I'm going to close it because that's the output at 3. And then after that, because I know it's a line and I have to point, I can get my ruler and sketch it. Watch what I did. I stopped at 3 because the output is 2x plus 1 for x less than 3. After that, there is a whole different formula that the function will satisfy. Okay? So when I pick the point, I will never take 4 because 4 is outside the domain. I'm not interested what happened at 4. I'm only interested in what's happening less than 3. Right. So this takes care of that piece. So this piece here is now right there. So that's y equal to x plus 1. That's this piece of the graph. Now I need to sketch the other piece. It means what happened here, minus x plus 6. Again, so this is now this one. This is also, if I graph it, I get a line, but I'm only interested in this line between 3 and 6. So this is 6. I'm only interested in it right there. It means I need to draw this line, but I'm going to restrict it to 3 and 6. I don't want the other piece of it because that's how my function defines. Again, it's a line. X minus x plus 6. To sketch a line, I need 2 points. And now we're going to think a little bit about the point. Which point would you want me to take? Remember, I'm only interested in the line between 3 and 6. Which point would you like me to take? 4, I'm going to take 4. 4 is here. The output at 4 is minus 4 plus 6. My output at 4 is equal to 2. So I have 1 point. So at 4, my output is 2, 2. That's a point on the line. What's the other point you want me to take? Another point you get 5. I will take 5. Okay, 5, I will have minus 5 plus 6 is equal to 1. 1, right there. Okay. Now I can draw my line, but I need to draw my line between which and which value. We have to be very, very clear. Only between 3 and 6. So this is 3 and this is 6. I need to draw my line between them. That 3 and this is 6. So that's going to be my line. That will be my line. Remember, that's only the piece. I will not keep going. It's between 3 and 6. Now, to have a good idea about the line, what I would like to do is, if this is 3 and what this should be should be open, but it's nice to know what this value is because it's going to help us a little bit. So if this is 3, what this should be? If this is 3, this should be minus 3 plus 6. This should be 3, but it's open because my function doesn't take this value. But it's nice to know what's happening here. These are the end point. So usually my advice to the student is always check out those end points because they can help you in graphing correctly. So at minus 3, it says 3. Even though they are not part of the graph, but it helps me to get a good picture of the graph. If it's 6, it's minus 6 plus 6, which is equal to 0. This tells me that right here, we are at 0. And that's really the graph of this function. It's a piecewise, it's a piece by piece. So the output here, this graph, this formula are exactly the same. We're reflecting this. Shouldn't be open circle? Absolutely. This is open. If you don't see it, I'll write it. This is open. This is closed. Okay, that's how the picture will go. Right? Okay. So what's the domain and the range? What's the domain of this function? Okay, based on what I have, what's the domain? And what's the range? All right. What are the input for which there is an output? Okay. Please, I want the answer on bright space, and I want a lot of you to participate, not, the same student. What's the domain? What are the input for which the output is there? Okay, I'm going to pick one. Adriana, are you with me? Adriana. Okay. Caitlin, are you with me? All right. Cameron. Cameron. Okay, I'm going to start counting those who don't answer that they are not with me. Cameron, are you with me? All right, who would like to answer? Amber, what do you think your answer is? What's the domain?
I thought it was 0, 6.
Oh, this is part of it. Why minus 5 is not in the domain? What's f of minus 5? If I take back here, if I plug in minus 5, can you give me the output? Minus 5 is less than 3. So f of minus 5 is going to be minus 10 plus 1, which is minus 9. So if I have minus 5 here, you can give me an output. There is nothing stopping you. The formula is giving you the output. Okay? Anything else? So will this change your mind about the domain? Anybody can fix the domain. So 6, you're right. That's the largest value in the domain. What about there? Everything from minus infinity to 6. Everything is in the domain. Is it 3 in the domain?
Yes.
Yes, so we don't have to
Yes.
break it, Alicia. We don't have to break it. That's the domain, everything up to 6. Okay, yeah, we don't have to break it anymore. What's the range? What are all the output values? So now I'm thinking about here. The range is on the y-axis. What's the range? Okay, I'm still waiting a little bit to see a minus infinity all the way to 7. Is it closed or open at 7? Is it, so this is 7. You guys are right. Is it open or closed at 7? Let us make up our mind. It's closed because this is 7. 3 is being, the output for 3 is 7. 7 is closed. That's my range. Okay. All right. Now the other problem we would like to do, and this one I definitely want you to try to sketch it on your own a little bit, and then I will ask you. Please, I want all of you to participate. That's the only way you're gonna learn. Okay. All right. Problem number 2. I hope I did not mess up this on Brightspace. Did I mess it up for those who have it? Okay. Another example.
I'm
I'm gonna do
so
that. Part A, we will do it together. Part B, I want to give you a little bit of time for you to kind of interact with the graph before I take it on. So let me start with that. What is f of minus 1? Okay, what is f of minus 1? Put up your answer on Brightspace, please, all of you. I want all of you to be part of this. Minus 1. Okay, this is my input. I go back here. Which condition satisfied? The first one, minus 1 is negative, so we use the first rule. Minus 2. F of 0. Sorry, f of 0. 0 because which rule? The first one, because 0 is less than 0, so it satisfies the first condition, so that's follow the rule 2 times 0, which is 0. F of 1, quickly. Minus 2, everybody's telling me 1 is between 0 and 3, so that's the rule. 3 times 1 minus 5, it is a minus 2. F of 3, F of 3. 4, she's right, because 3 is bigger or equal to 3. So it satisfies this condition, so the output is 4, and F of 4 is equal to 4. Okay. Now we want to graph. And I want you, I don't see you, you guys know that, but I want you to be honest with yourself. Pick up a piece of paper, try to graph, and see what you can do with it. Because graphing is where I usually shouldn't have a problem. So pick up a piece of paper, then I will do it in front of you. So you know what you're doing right and what you're doing wrong at the same time. Please, every one of you, try it. Okay, in 1 minute, we will get together and I'll start asking you what you came up with. So I'll give you 1 minute. All of you, please be responsible. All right. Okay, we're gonna graph it in the last 3 minutes we have. Who would like to tell me, just tell me how would they start so I can work with them. Who would like to take the lead? Don't make me choose. One of you take the lead. Tell me, what did they try? What did you do?
I tried to take the 2x.
Yes.
I just moved 2 spaces along the x-axis from 0, and I just put a point.
Okay, so you use that, it's a line, so you use the idea of a slope, right?
Yeah,
So how did your line looks like? Can you describe it in word for us?
it ended up being the way that I did it, it went up to the right, so it was positive to the right.
Where did it stop?
It went on for infinity.
It means something like that.
Doesn't
What?
it have to stop at 0 for
It has to
it
stop at 0. Yes. It has to stop at 0. Okay, so y equal to x, you're right. At 0, it is 0. It goes all the way this. That's 2x. But sorry. But we want it to stop where? We want it to stop at 0. So when you're graphing, this piece has to go. You stop right at 0. Do you follow me what I said? The student will, okay. All right. So the first piece, up to 0, we have one part. So up to 0. So I can take 0, 0 if you want, or 1 and no, I cannot take 1. I have to take -1, which is a -2. I did not take 1 because this has to stop at 0. So at -1, I am at -2. And at 0, we are at 0. And now I pick up my line and I stop up to 0. So the graph is going to look a straight line. You know, I forget when was the last time I used a ruler, but today I'm using it. And we're going to stop exactly at 0. If x is 0, the output is 0. So that's a nice closed circle. That's the first piece of the graph. You stop here. You don't keep going to infinity because this is what your input is about. Now, what about 3x minus 5? Who would like to take the lead for that?
We could do 1 and 2.
We can do 1 and 2 because I
Mhm.
have to restrict myself between 0 and 3. So 1, 2, 3. So I'm going to put my 3 here. So that's x negative here. Okay, so she tried 1 and 2. And then I'm going to make a little bit of a comment and you guys will. So 3 minus 5, which will give me -2 in here. And am I right? I'm goofing. Am I right? Yeah. At 2, I will have 3 times 2 minus 5, which is 6 minus 5 minus 1. So at 1, I am at -2. And at 2, I am at 2, I am at, what am I doing wrong?
6 minus 5 would be just a 1.
Sorry, my mind went blank at this stage. 3 minus 5, that's going to be a -2, and that's 6 minus. What am I doing wrong? My mind went blank. 1, I am at -2. And at 2.
So that's a positive one. I made the same mistake.
Ah, okay, all right. That's why, but the graph isn't working because that's why I'm stopping here. All right, that's +1. Very good. Now I need to draw my line, but I have to draw it between 0 and 3. I have to draw it between 0 and 3. I cannot go any further. So I'm going to take my nice ruler and I'm going to draw it between 0 and 3. Well, this is 0 and this is 3. Okay. All right. Now, if I want to be precise, what do you think I would like to know? What do you think I would like to know? To have a good picture. What I would like to know is what this value should be. Now, because I have a perfect graph, it's -5, but let me make sure. If x is 0, this should be -5, but that's open here. But I would like to know this value because it helps me in the process of graphing. Now, at the other end, point 3, what this value should be. Can anybody tell me? I know it's open, but it's nice to show that it's open where. Can anybody tell me what this should have been? Means I'm looking at the end point because I like to know what's happening at the end point. That's what I mean end point. So at 0, it should have been -5, but I know it's open there. And at 3, it should be 3 times 3, 9 minus 5, which is going to be 4. So this open here is at 4. It's nice to know it because you have a good graph from there. Now, the last piece. Okay. If x, so this is 2x, that's the graph of 2x. This is the graph of 3x minus 5. For x bigger than 3, what is the picture? If x bigger than 3, the output is 4. At 3, it is 4. So this open circle now is going to close again because that's the value at 3. And everything before 3 is going to be constant because the function is taking always the value 4, 4, 4. So this is the last piece. This is the y equal to 4. That's how we're going to graph it. It's a little piece by piece. That's what we call a piecewise defined function. Okay. Next time, what we're going to be doing is I will give you the graph. You have to give me the formula. Next time, we're going to go backward from the graph to the formula. All right. Any questions? Okay. So for Tuesday, 3 things. First, you're going to have a quiz. And your quiz will cover domain, range, and what I did today. So it's going to cover section 2.1, 2.2, and what I did from 2.3. So do the practice problem. That's the first thing. The second, that your online homework is already on Moodle. So online homework. And it's due a week from today. So it's due on Thursday. And finally, what else? Do your practice problem. Do your practice problem. All right. Any questions? Anyone?